Thank you, everybody, for joining us. I'm sharing my screen right now, right? Um,
Yes.
Today we are going to be doing part 4A, and the A I will explain in a little bit. But my name is Natalie C. I am a structural engineer. I've been living in the Bay Area for about 20 years. And joining us, we have Mike Koralik. Mike Koralik is the principal at Tipping. He's been with the firm for about 19 to 20 years. Um, so for today's tutorial, we're going to be going through 2D structural analysis, which is one of our great features. But in today's example, we're actually covering composite beam sections. I've added a QR code for those of you who will be referencing our YouTube videos later, but this QR code will bring you to the recording for part 4, where we go through an example for a steel beam, as compared to today, where we'll be doing an example for composite beam section. And also, at the end of the tutorial, we'll be talking about viewing and plotting your results. But before we dive into that, we're going to do a quick review of what we went through for part 3 tutorial. So that was on fiber section analysis. I'm going to let Mike take over here.
Great. Thank you so much. Um, so yeah, quick review on fiber section analysis. I wonder if I have those tutorials handy. Let's see if I can pull them up quickly. Tutorials, fiber sections, and I think it's going to be this one. This would be the file that we. Oh, sorry, I didn't complete sharing my screen. There we go. Um, Yeah, so this is the example that we walked through in with the fiber section analysis last time. We created a shape here, which was supposed to represent a wall 29 feet long, and we used the expression dimension here. I can go ahead and show the measurement so you can see what that is. So it's a 2 foot thick wall, and we tagged it with the tag XS wall, and we put in a bunch of rebar in the wall. We had our uh, uh, row target here. That's the steel ratio that we were looking for our web bars, and then we had a bar spacing, and so this led us to determine what size bar we wanted to use here. We can show the bar size. I'm kind of forgetting what I had done, so if I select these bars and I start to type bar size. I can see a bunch of different options, and one of them here is display size. I click that, I click yes, and so I see we wound up with number 11s and 6s, according to this area bar that I calculated there. We created an expression for the strength of concrete and rebar, and then we use the fiber material sidebar to create these fiber materials, and they like there's our concrete material referencing our concrete strength expression, and the rebar material referring to the rebar strength expression, and then we also had a confined concrete bit here that we drew up later in the analysis, and I can always double check what's what by checking the box to override layers, and I can see here's my confined concrete material, my rebar material, and my unconfined concrete material. And then we showed that you could do a moment curvature analysis of this wall, selecting everything here and typing MR, and it brings up the fiber section analysis form, and you can click on a point on the moment curvature diagram, and you can kind of see how the cross section is behaving as you go along the moment curvature diagram. And then you can click on fibers, and you can kind of see what the stresses in the fibers are as you go along the moment curvature diagram. I'm just pushing the arrow key as I go along here. And I can kind of see what's happening as my rebar eventually gets up to near the yield strain, and it kind of sticks right there, and then ultimately get some strength loss. And I wonder what's happening there. I think it's probably this. The cover is starting to break off there. Maybe I'm getting some rebar fracture on the back end. Ah, yes. So I'm starting to lose strength in the rebar on the back end. So we showed a number of those things. We showed that you could do a PM diagram or moment-moment diagram of this of a cross section. And then we also showed that in addition to the fiber section analysis form, we can use functions to get the same information. So we selected this guy, gave it a tag, XS wall, and then we use the get phi m theta get phi, which is I'll do the control P so you can see what's in here. Get phi, and then this little tilde with a Q gives us a theta. We write in the tag. We write in 0 for 0 degrees. And then we put in the axial force if we have an axial force to consider. Compression is negative. We run that and we get some data. It's an array. We can always show the array if we want. This is rendering arrays compact. Say no, and then you can see there's all of our data in that array. Turn that back. Oops, turn that back to yes, so we don't see all that. And then we showed you could graph this. I have these series on here, but to add a series, we push SER, add series, and we can go to vectors, which is just plotting arrays of data, and we say X expression includes X, Y pairs, and then we type in a reference to the symbol MR1, which is right there, and we click add, and now I just re-added that series. We type EDS, edit series, to bring up the edit series sidebar, and I delete the one that I didn't want. And I showed in here that you can control all kinds of attributes of the series. You can change the hue if you wanted to, and they'll stick with the same hue. Or let's say you didn't want to change the hue, but you just wanted to lighten them both up, but keep the hues the way they are. You can just click the L and slide the L along. And saturation is going to give you some either all the way to gray or all the way to fully saturated, or transparency, A for alpha. I don't know why it's called alpha, but that's the way it's called in programming world. And you can shift the transparency along that way. So lots more to talk about on graphing. We're gonna dive into graphing in its own special tutorial coming up soon. And that is the summary of fiber section analysis. Anything in there that somebody wants to hear again, or anything that was unclear before we move into the new content today?
That was a good summary, Mike.
Thanks, Natalie. Okay, so let's dive into today's content, which is going to be structural analysis in Sketchulation. And as always, I invite you, if you have a question along the way, please feel free to interrupt me. I love to take questions and have the dialogue going. Okay, so we have our page here. Always good to start with a page that really provides a boundary for what you're going to print later on. We have added a new feature. If you draw a page now, it will insert a page block along with it. So you can determine what your page block will be, and it adds this title pre-done. So here I'm going to have my analysis example like that. And I'll delete the old page. So here we go. We've got our page laid out. And what we're going to do here is use the program to say, check and design a simple span steel composite beam, and walk through how the program works in that way. The way to draw an element, a structural analysis element in Sketchulation is you want to think frame element as opposed to, say, a bar element or something like that. FE is the shortcut. Click that. Bring this up, and let's say our beam is going to be, standard 30-foot long steel beam. I start to draw this. I push F8 to get into the angular constraints. I push 30 and apostrophe for the feet, and it lays out a 30-foot long beam for me. I look at how that lands on the page, and I might feel like that's pretty good in terms of how it sits on the page. So I feel like my annotation scale is all set. I don't need to rechange that. Now we're going to draw in the restraints at the two ends of the beam. I'd start to type RES, and the shortcut for that would have just been R.
Mike,
Uh,
can you turn on the keyboard
oh, of
display?
course.
Sorry,
Thank
I
you.
forgot to remind you earlier.
Thank you. That's my fault. I should have done that. Okay, there you go. So I popped in one restraint. I push enter to repeat that command. And now I have the two restraints for my pin beam. The next thing we might want to do is add in some loading. So we'll create a couple of quick expressions for some loading. I type XD to add an expression. I type W, we'll call this W dead. And let's say for our steel building, we're going to have 50 PSF for the concrete over metal deck. And then we'll have, say, another, 25 PSF of superimposed load. So I have 50 PSF plus 25 PSF, and that gives me up to 75 PSF. And then W live, let's say we're going to design for 80 PSF live load. And then let's say these beams are spaced 10 feet, so I'll say B is equal to 10 feet. And so that leads me to a linear load for the dead loading equal to W underscore dead times B. And that gives me my linear load for dead. And then W live is equal to W underscore live times B. This is my live loading. So I have those defined. And let's say for fun, we also have a point load. In addition to these loads, we have something special going on. We'll call this PD is equal to W dead times, we'll say B squared. I'm sorry, W dead times B squared. There we go. 7.5 kip live load. Point load. Here we go. So now we're going to draw in our linear loads. You can start to type linear, and you'll see it says load linear, LDL. I have that one burned in my mind. LDL, and now it's asking me to select the points on the beam where this will go. Just for fun, I'm going to not select the full ends. I could snap to the ends, but I'm just going to show that you can do it anywhere along here. I typed F2 to start to edit this thing, and I put in WD. So now it's defined with my dead load. This linear load has a bunch of different options to it. You can, for example, do variable load. So that would be linearly changing load. So let's say one end of it has 0.5 WD. That's how the load would look. We'll talk about load sets in a second. You can hide expressions if you don't want to see them. Change the expression system. It's worth noting that the line loading is tied to an expression system, so it's referring to this version of WDEAD. If we had different expression systems going on, we might need to pay attention to that. And then there's some other features for how these things will appear. Okay, so I have my dead loading defined. I'll go ahead and just make that not variable anymore because that's silly. And then I have my live load. I want to create my live load. You'll notice that there's a little grip here. You can select that grip and slide it around just to make space near the frame element. So it's just graphical. It's not changing how the load's applied. So usually, you put that all the way down, but it is helpful to take this grip and create a live loading. So I select the grip, and down at the bottom, you see there are certain options. And if I click C, it makes a copy of this, and it changes the instructions down at the bottom. Stretch a copy is what it says now. I click this, and now I have two versions of loading. I double click in there and change that to live. So now I have my dead load and my live load on the beam. And then I'll put in my point load, PLD right here. Let's put it in a random location. And I will double click into that and give it my point load expression. So now I've got loading on my beam. The next thing to do here is to put that load into load sets. So you're probably familiar with other programs where you have load sets and load combinations. And in Sketchulation, you have load sets and load combinations too. In addition to that, in Sketchulation, you also have load sequences. So load sets. I start to type load. Here it is. The command is load ls, but then you see underneath it LC and LQ. I start with the load sets. I click this and it brings up this sidebar editor. And what we'll want to do is add a dead load set. So I select the new button and I give this new load set a name, and maybe I want that to include self-weight. So now I have a new load set that I can then assign to my dead load loads. And I can always double check to see if that took by checking the box to override the layers. And then I'd want to make a live load set, call that live, and then do the paintbrush again, select my live load. So now I have live and dead loads. The next thing I'd want to do is make load combinations, and this is where things get potentially very time consuming. You don't want to have to deal with remembering all the different load combinations and transcribing them into your program. You can, of course, so I'll walk through how to create a load combination. I'll just leave the default name there, or maybe I'll give it, D plus L, like that. And the way we do this is we select a load set from the list. We give it a load factor. We click plus to add it to the list. Take live load, click plus, add that to the list. And so now I have my load combination here. Of course, I could give it different scale factors if I wanted to. So that's my first load combination. It's all set. Now, we're going to come back and talk about the easy button in a second to batch create load combinations. But first, let me explain load sequences. So LQ, load sequence. In Sketchulation, as opposed to other programs, you can actually put the load in or have the load be applied in steps. And this is useful if, for example, you have a construction loading case where you want to make sure that, like in our case here, actually, we're going to have a composite beam. We'll want to know if the steel beam can support the wet concrete unshored before the studs that are part of the steel beam start to do their composite action with the deck. So that's one reason why we might want to run the loading in steps. Another reason could be that you have an element, a column, let's say, that exists for live load, but it doesn't exist for the initial construction. So in that case, you would want to ignore that element for the dead load, and that's an option that's within the frame element. And then you would want it to be not ignored for all live load cases, and that's another reason why you would do load sequences. In 99% of cases, you are not going to need to do anything special with the load sequence. You will just have the load sequence mirror what the load combination is. So in a load sequence, you select a load combination, you give it a number of steps in which to apply that load, and then there might be some special context like the composite beam, which we'll get to in a second. And we click plus, and that adds that load combination to my load sequence. You will also want to give it a context that tells the program what to use, how to use these load sequences for designs. So for example, is it ASD or LRFD? And in this case, I would call this ASD long term. So now I have my load sequence combination and load sets all set up. Now I would have to repeat this for all the different load combinations that are in the code, but here the wand comes into play. I can click that, and we have an automatic load combination generator here. On the left, you would click the various load sets that you have in your analysis, and then on the right, you'll select the load combinations that you want to use. So if I, for example, add E, then all the earthquake load combinations get added. There are options down here on the bottom. Do you want LRFD and ASD or just LRFD? You can add deflection only combinations like just live load, for example, or snow or wind. You can decide whether you want plus and minus earthquake and wind combinations. And then for our case, we do want to create this construction load sequence, again, for the composite beam problem. And then you have this option of whether you want to overwrite existing load combinations. And what that will do is it will, if you have load combinations that are the same name, load sets that are of the same name, load sequences that are the same name, it will override all those with updated settings. And also you have the seismic parameters too for the earthquake loading that contributes to the vertical component of load. So I select the load combinations that I want. I click OK. And you see that it didn't do anything to the load sets because I happened to name those the same as what they would have been named automatically. But you see it added all these additional load combinations for us with their various load factors. And then it also added load sequences to the load sequence list. And then we will also see here, because we did the construction feature, we have these, the dead load is applied during construction, and then the live load is applied separately. So we start with 1.0 dead load in this 1.2 dead plus 1 point live load sequence. We start with 1.0 dead, then we add 0.2 dead plus the live load in a separate step. So that's what that checkbox affected for us. Okay. Any questions on the load sequences and combinations and whatnot?
Can you talk a little bit the validate button, Mike?
Yeah, the validate button will happen automatically when you run an analysis, but there can be cases where you have invalid inputs, and so this just double checks that, and you can click all of them at once and click validate and just verify that there's no errors in the inputs. And one thing I should point out also is that it did automatically set the context. So this is an LRFD long-term load combination versus, say, this one is an ASD. Also, it is important to note that the dead load is automatically going to include self-weight. And if for some reason you didn't want that, you should uncheck that box. Any other questions? Okie doke. So I will close these guys. I have my loads assigned to their proper load sets. I'm almost ready to run the analysis, but the last thing we need to do is to set up our cross section. So what I will do is create a frame element type, FET, and it brings up the sidebar editor here. I click new for a new cross section, and here we have a number of options with standard design rules, the AISC, ACI, NDS, so steel, concrete, wood, and then rods, which are a version of steel. These would be more for like pre-stressed situations, pre-stressing rods or strands. The steel shapes we'll see in a second. We'll dive into that. You're going to select either shapes from a standard database or enter your own properties. The ACI version relies on a fiber section tag, so you would give the program a tag, and it will use the fiber section for the analysis. And then with NDS, the wood sections, you have the standard sections and materials, and it'll follow the NDS rules for design, similar with I-joist design. So we're going to select AISC, and we're going to select a standard cross section out of the database. If you had something that wasn't in the standard database, you can use the AISC design rules with one of these common shapes, circular tube, rectangular tube, etc. But what we're going to use is say a W18 by 35 for our basic beam. We'll have to see if that works. I'm not sure it does. So I selected that out of the list. You see all of the properties of this section are grayed out. You can't type into them because they're coming from the database. You can rotate this if you had a weak axis bending situation. This is how you set up the orientation of your cross section. In our case, we would just have this straight up and down, so 0. And then you do set the yield stress of your cross section here at the bottom, and then there's a color contour options that you can use. So we click out of here, and now we have our cross section defined. I can click the paintbrush and apply that to my frame element type and push enter. And now we see we got this reaction applied frame element model W18 by 35 to one entity. Okay, so and then you can also, within this frame element, you have some options. One of which is you can display the element model that you have. So there are lots of options. We'll get into most of these in a second. Where is that the label? If I can't find something, I'll go up to my filter and start to type label. There we go. It's in geometry. And you can display the length, 360 inches, or you can display the element model, W18 by 35. Okay, so now my analysis is ready to run. I have valid restraints. I have a valid model. I have a valid a set of loading. So I can run the analysis in two ways. I'll bring up the structural analysis options sidebar. I always type OPS and hit enter, but it's here. SA, I guess, is also the shortcut. And you see the program has identified one model. As you're drawing valid analysis entities, it's building a model, and so it already knows that the model is built. And when I click in the list, it highlights that model. So if I had multiple models, I'd have many things in the list, and I can identify them by clicking on them. I click the Analyze Now button, and when I do that, it runs the analysis. It says that the model one was analyzed. I can double click on that if it didn't analyze for some reason, or if I just want to see more information about each of the analysis cases. So it runs through and tells you what it ran and just basic information about what happened. The program does nonlinear analysis with like cables and fiber sections and stuff. So sometimes you might have convergence issues, and this is where you would go to try to figure out what's going on there. But you see right now we have this checkbox check that says view results. I can uncheck that, and it shows the undeformed shape of the beam, or I can check it and I can take a look at what's going on here. There are all these submenus, so I'll just expand them all, control and click on that. And you can see here, what I'm showing right now is this analysis case that's highlighted, the dead plus live, which is the one that I created. I can click on any one of these or all of them and see the envelope of all the results. And you'll notice that they have this 1/1, so that has to do with applying the load in a sequence. So this is dead load applied one step out of one total steps. And here I see this is the dead plus live, dead only, and then dead plus live with the live added in. And you notice that matches up with my one-step dead plus live sequence. I can also select envelope by context, and it's going to select just those load combinations that are the ASD context or whatever I've chosen there. I have some other options here. I can show the deformed shape or not. I can show factored loads and reactions. Let's get this off of the, we'll just look at our dead plus live case here. So I can see what my loads and reactions are. Let's see, what else can I show? I can do some things with the deflection labels, turn those on and off. The displacement could be in components versus as an SRSS, the total displacement. The reaction could be also in components. Since there's vertical, it's not very interesting. And then I can also, let's see, if I turn off the loading, I can show, my diagrams, like my shear diagram. In this case, I probably wouldn't show the deformed shape, or the moment diagram. Why is it not showing the moment diagram? Hello. Oh, it didn't want to show the moment diagram and the shear force diagram at the same time. I'll look into that later. But anyway, there's my moment diagram, and etc. You see all these other things that can be shown. I can show, interestingly, I can show the DCR. So the demand capacity ratio, this guy is not working very well. It's got a DCR of 7. And then I can also have it color by the DCR. So I'm going to need to upsize my beam in a second here. Then other options here, you have convergence tolerance. That's really not relevant for the typical case because the linear elastic models converge all the time. But if you have a more complicated model, you might adjust some of these convergence settings here to help the model converge. And then you have options here like the load scale and the graph scale. So for example, if I want to see my diagram a little bit bigger for printing, I can increase the load scale. And then you have options for units, display units down here. So typically, what you'll do in your analysis, I always, I leave it sort of as the deformed shape and I just show that like that. But typically, it's not great to use the program in this way. It's very quick to see kind of a result if you're just interested in a very quick calculation. But if you're going to produce something and print it in a report, you'll want to do something slightly different. It's not very effective to use this in this fashion. So normally I would uncheck the view results, and then I will use this command VPM viewport model. And what this allows us to do is to view all of the element results all at once without having to, click a bunch of checkboxes. So when I start to run the command, it's now showing all the diagrams that are available. So that'll help me to know how big of a viewport I should make. And I'm going to use that to make a viewport that's, say, this big here. And then I get some options that come up. I can choose whether I want to show a viewport with factored loads and reactions. Maybe I like to see the reactions for the dead plus live case. And then deflected shape. Here I could pick an individual load combination or just do an envelope of the ASD, which is normally what you'd want to do. And then similarly, the analysis for things like moment and shear and DCR, probably want to do all of the LRFD. You could do ASD if you wanted to, if you're more comfortable with that. It runs the DCR checks both ways. So when I've got the settings that I like, I click OK. And it has created these viewports that I'm now just moving around. I click F8 to line this thing up vertically. I click a point here, and then you can scale the viewports, but I usually just click Enter to make them the size of the beam that I'm analyzing. And here are all of the viewports showing the results that I requested. You'll notice here that the factored loads and reactions, they got clipped because my viewport's a little small. So I'll want to adjust this so that I can see all of the information here. So I select these grips and I just move them up a little bit like that. Can analyze the model by pushing F5. And so here we are again, back to where I wanted to be. I'm not going to mess with those viewports until I get that bug fixed. But here you see we have all of our results here in the viewports. I got my deflection, DCR, moment diagram. You see it's plotting all the moment diagrams for all the LRFD combinations, but it's only showing the label for the maximum case. And then we have the shear force diagram right there. And so that's the basics of doing the analysis. And the next stage, I would go back and make this a composite beam and see if that works. Probably have to upsize my 18 by 35, but I want to pause here and just see if there's any questions that anybody has. Any questions? Yes.
I might. Can we now change the restraints? I mean,
Yeah.
Can we
Yes.
change now in model?
Yes. Yes.
Yeah. Make
So
it better.
yes, you can select the restraint, and the restraint has a number of options. I typed MO to bring up the modified properties sidebar. Bring up my keyboard monitor again. Here we go. And so here are your options for that restraint. Right now it's an X and Y restraint, but I could make it fixed, let's say, for moment, or I could make it, let's say, a roller. Let it be, oh, that's not what I meant. I meant this. So that's how you can change that. And you could have a moment with a roller. And then you also have options for springs, stiffnesses in the restraints instead of having them fully fixed, and tension and compression versus compression or tension only. So once that's done, I can just rerun the analysis, and then we see our updated results.
Thank you.
Yeah. Other cool thing in the analysis options menu, I could turn on auto analyze, so that immediately if I make a change to anything, the analysis automatically reruns, and I get the update right away. Any other questions?
Another one also. Sorry. Um, how complex we can make the frame? I mean, that if you in this model, let's say we have a frame.
Mm-hmm.
Is it the same way it works? I mean, if it's a movement frame, 2, 3 story or
Yes,
whatever.
yes. I mean, it's very easy to make components or make models as complex as you want. It can handle pretty large models, I would say. I mean, what I've tried, I've done a number of like different trusses and things like that. The nonlinear models with say soil springs and if you're doing concrete creep, some of those take a little bit longer to analyze, but it's not prohibitively long. I meant to make a copy of this, but I was talking here. So here I've created a moment frame. I put in my restraint like that. I put in just making things up here as we go along, but I put in my point load. I rotate it like that. I selected the grip and then pushed enter twice. And let's say I put that as PD just for fun. And so now I have a moment frame. Let's say it was multi-floor. I copy it like this. And there we have our moment frame. And let's just say for fun, these are all 18 by 35. So I select them all. I bring up my frame element type editor. I do the paintbrush. And then now I'm good to go. I can just run that. Let's see here. OPS. Oh, it says my model's invalid. I wonder why my model's invalid. I double click on it. And I look at the validation log. It says load invalid, not member of load set. I see what I forgot. I forgot to assign this load a load case. And in this case, I'd probably want to put that on seismic, but for just my little example here, I'll just call that a dead load. I put that on the dead load case. And then I click F5 to run the analysis. And again, it says, what does it say? Not all converged. And I look at this and I ask myself, why is it not all converging? All of these are converging. Here's one that's not converging. So I'd have to go in and look at and try to understand what this guy is doing. But the analysis cases in here, if I view results, I can see the results on that. This one is the one that didn't converge, and I have to look into that one why it didn't. But anyway, you can run the analysis like that, and you see it doesn't take any real time to run. I can quickly get my moments and shear force diagrams in the same way that I would have done before. So
Thank you.
you're welcome. Any other questions? Okay, so the next thing we want to do is to change this to a composite beam. And probably what I'll do is, normally in a composite beam, you'd want to make sure that your beam is working for dead load, and then you'll double check it for the live load. So what I'll do here is I'll look at my DCR printout here, viewport, and I'll go to adjust the dead load case, and I see that my dead load DCR is 3.37, so that's way off. One thing I would also want to point out is you can have view results going here. Turn that off. You can also double click, or I mean, select one of your the frame element, and you can type DCR, and you can get a printout of what the DCR calculations are doing. So for example, on this dead load one, I can click on that case and I can walk through how it's doing the calculations and coming up with that final DCR of I think we said it was 3.37, yeah, where the high moment is there at the fixed point. I'm gonna turn that off because that's not really what we would normally have. I can change the restraint here to not be moment. Okay. So now we see that our dead load DCR now it's gone up because I took away that fixity, is 4. I'll go back to my frame element type, and I want to get that DCR to be 1 under just the dead load. So I double click in there, and I figure I'm going to have to go to a 24 by 55 or something like that. So I'm just going up in my list. I find that. I click out of there. It already updates. It's a reference to that frame element type. So it changed the name for me and updated the frame element right away. I push F5. I see I'm still not working with a 24 by 55. It's now a factor of 2 off. I'm going to stick with the W24, but maybe, let's see. I think I'm going to have a hard time with the W24 actually. Oh, that worked. 24 by 84 worked. Pull this down. Let's go 24 by 68. There we go. 24 by 68 is working under dead load, so I'm good to go. And I can see my deflected shape here is 0.67 inches. Now this is non-composite, and this is not terrible deflection, but if I want even better deflection performance, then I could go to a composite beam, and that's what we'll do here. So to make a composite beam, we go back to our frame element type, we click the new button, and we select the AISC composite beam option. We had to already define a cross section because in order to create a composite beam. So first we had to define that 24 by 68, and then now we have it in the list here to select, and you get a printout or an illustration of what the concrete mesh is going to look like. And you have options for your composite beam, things like the ribs. So this is describing the decking, the rib width, and then the rib height, stud diameter, and all that kind of thing. So these will be things you would check into if you're doing your composite beam design, concrete strength, and whatnot. If I'm happy with these properties, I can click out of here, and here's my W24 by 68 composite. And now I can paint this onto here and type F5, and we see the frame element type has set up with this W24 by 68 composite, and immediately I'm a little confused. I was wondering why my dead plus live load didn't change much. It should have reduced the deflection if my composite action was very effective. And so I'm wondering, okay, what's going on? How come it's not making much of an impact? And so here I'd probably try to dig in. Probably the case is that I haven't given enough studs to give good composite action. So the amount of composite action you get is going to very much be dependent on the size of your studs. So normally we probably want these to be like 3/4 inch studs. And the rib spacing, the stud spacing, maybe we put that in as 6 inches instead of 12 inches. I click out of that, and then I rerun the analysis, and you see my deflection just decreased from 0.67 inches to 0.5 inches, which is a nominal increase. May not be worth it, but this is how you would you can work with the inputs for the composite beam and ultimately get the design that you're looking for. One thing we also notice here is that a lot of the deflection is coming directly from the dead load case. So we can select the analysis case that's just the first step, and we can see we're getting 0.4 inches of deflection right from the dead load, and that's going to be the wet concrete non-composite section. And then with the composite section, we're getting only an additional 0.1 inches, and so that's the effect of the composite section network. Any questions? Okay. Now, lastly, I wanted to show that you can, in addition to seeing the status of the design through these viewports, you can also get results from the frame element through functions. So I can tag this frame element, start to type entity tag. So here we are, and I give that, say, a tag called lowercase bm. And that displays right next to the element model there. and I can query that beam to get its, say, its peak moment. So I'll make a new expression, and I will say M, call it MU. Now, there's a couple of different ways of getting results out of a model. There is the elRes, which is the more basic version, and then the elEnv. The elRes is going to give you a result for a particular load combination. So I push tab to get that function in there. I give it the beam name, BM, and then the load sequence. So this is going to ask you for a particular load combination that you've run. I click this guy, 1.2 dead plus 1.6 live, and then let's say I want my moment. Now there's a lot of different results that you can get. If you want to get a detailed description, you'll go click F1 and search for frame element, and you'll see all the different results. We'll do that in a second. And I want just the absolute moment. I don't care about positive or negative. Push the arrow, and it is giving me this moment here. I'm going to slide this down a little bit so we can see it. And that moment is going to match up, you see here, with what the moment diagram shows, which is reporting the same information. Now, if I wanted to, let's say I wanted a different load combination, say dead plus live, I just double clicked on that and delete the remainder bit there. And so this is my moment from my different load combination. Now, if I want to make sure I'm getting the biggest, that's where I would use elEnv, which stands for envelope. So here I type that in, elEnv. You still refer to the beam, but here instead of the load combination, you refer to a context. And this is where that context comes into play again. I will pick the LRFD context. And then again, everything else remains the same. And what this is now doing is it's finding the largest value of absolute moment from any load sequence that's labeled as LRFD, which is the same number that we'd looked up here. Any result can be queried this way. You can also look up the result at a given location. So if I make an expression here and I start to type L, you can see all of the different versions of functions that you can use. So elRes at will give you a result at a particular location along the beam. elRes step will give you a load or a result at a particular load step. Let's say if you have a load sequence with multiple steps. And there's some other more complicated versions of functions here that you can look up. And again, if you wanted to see the set of results that you can print, I clicked F1, I started to type frame element, and here you see an explanation of all the different results that you can query from the analysis, and there's a lot of them. Okay. Any questions on any of this? I think that's
Okay. My question was, Mike,
yes.
can we have a result of output in a table form? I mean, combination versus the maximums.
Yes. So I will make a table here. And why don't you tell me exactly
Let's
what
say
you're
we have, for all combinations, we need the maximum moment and shear, for example, and deflection. So
Okay, so what you would want to do if you wanted to see there's a couple different ways to do this, but if you wanted to see them here, we would make a column here. We would need to make sure that this is the right name. So let's say 1.2D plus, and there's some spaces in here. This is a new question. So one of the things I'm wondering is that typically, yeah, the best thing to do is going to be to like copy these names out, although I could easily make a little table view to copy them all at once. But anyway, the name needs to be perfectly correct. And then what we would do here is, let's say, go copy this, and I would type that in there. And then here we would change that to elRes. And then we would replace this with LC like that. And then you could do the same thing for the V, like that. Oops. Don't give it the same name though, because that's confusing. Like that. Is that get at what you're asking?
Yeah, and I think it will be nice if we have a button somewhere in the result analysis report when we click it and we have this table prepared. I mean, that will
Yeah.
help in the design process, I think.
Okay.
Yeah.
Yeah. That sounds good. I have there is something in the back of my mind. Um, what was it? Somebody asked something similar. Where did and I have to remember what they asked something similar, and I want to make sure I get that clip response. Um, what do we have here? This will give you the actual the response in a table form just for a particular load case, but this is along the element, so
Mm.
that gives you the location and the various data, and you could do that for multiple load cases. That actually I think kind of gets at what you're wanting. So let's see here. If I go back to this, there's extrema versus response. Extrema is going to give you the max along the element. The response is going to give you everything. And so let's say I could be interested in all these load combinations, but if I were only interested in, say, dead plus live and that guy, 1.2 dead plus 1.6 live, the second step there. I click OK. It puts the results in the clipboard. Now I make a table and I go in here and I push Control V. So this is going to give all of the information right there. I would indicate the first row is a header just in case there's any invalid stuff in there. I click OK, and there you have the data. Now again, this is giving you all of the responses at every location.
Mhm.
And the extrema would just give you it would condense the load case into just one row with the worst case of all these results.
Okay. We can sort it here, maybe the
Yes.
repetition and just okay.
Yeah, you can, in any table, you can select a cell and you can right click. And I always do this by the quick keys, but Control U to sort the entire table like that. Um, Control U, Control D, like that. Um, Now, is that close to what you're looking for? I can show here,
Ye-
how the
Yeah, it's close, but I mean, if it's more less data, but the important ones as a
hmm
basics for the load combinations and just will be nice to have a standard table for the all output when you have a
uh-huh.
analysis and then you have a result. Very
Yeah, I
clean
think
for
what I
design. I mean, you can go back, you can, and I mean, just you understand how the all performance is versus the all load combinations, and then it's
yeah.
accelerate your design changes.
Yeah, I
Hmm.
think it would be good to know. I mean, this is also something you would do by hand. I mean, there are a lot of one of the things I've you'll notice when you're doing the design checks is that there are a lot of design checks that are quite complicated. And one of the things I forgot to mention here that I should have is that the unbraced length makes a huge difference. This is why my beams weren't working. They were in such bad shape. Is that the unbraced length was set to -1, which means that the whole element was unbraced. So you want to make sure and set that to 0 if it's fully braced, or enter in your brace spacing. The reason that I brought that up is because if you look at the actual DCR checks, there are lots of things going on that take into account combined loading, slenderness checks, and all kinds of things. And so in the past, I've been reticent to provide this kind of table information that would then be used for design because it'll always be less complete than what we're doing internally. It's nice for a check, and I use
Hmm.
that from time to time to check. But I would just want to provide a word of caution on that. Now, I love to get suggestions for feature requests, and so I think if you showed me an example of what the table would look like, exactly what columns you'd want to see and the outputs, we can certainly do that. I'd be curious to know your suggestion there. And the best way to do that, you could either email me directly or you can bring up the user forum, and there's a feature requests board there where you can make a new topic and provide the request there, and then we'll review it.
Yeah, okay, thank you. And just a quick one, and the design table, if you add the metal light gauge table will be nice also. I saw that all steel, concrete, they are there, but
Yeah.
today actually I was using it for the light gauge design, and I saw
Yeah.
that there is no that table for this section. So
Yes. Yes. Yeah, that's now the second time that's come up, so that's something that we might consider. The design rules for light gauge are very complicated. It's all controlled by local buckling. So we've just hesitated to do that, but I think it's clearly if there's interest, we can put that on the list of features to add.
Thank you.
Thank you.
I just had a quick question. I'm assuming you can link loads, like if you had a second beam element and you made that be like a reaction from your other beam.
Yes.
And it would all update.
Yeah. So the way you would do that is you would tag this guy, the reaction or restraint rather, and I can just give that say RS like that, and so now he has a tag. You can create you can get the reaction for a particular load combination, or you can get the envelope elEnv in the exact same way RS. And then you would probably want to the difficulty here is that what you would want to do if you're doing another beam that's reacting to this, you would want to set up load combinations to pull out the dead load and the live load separately, so that this would be R sub dead, and instead of using elEnv, you would use elRes, and then here I would find my dead like that. And so this would be R sub D, and then the result name. This is where I have to go back and dig deep in my mind to see if I can remember what this is. I think it's this guy. So there's R0 and R1. The 0 is going to be the X direction, and the R1 is going to be the vertical direction, which is probably what you're interested in. And so I have my load there for dead. I would want the same thing for live, and then of course I can make a new frame element here, put in new restraints, and then a point load like this, and then set this to RD like that. And then that will, whenever the model on the left changes, the model on the right will also update.
Awesome. Thank you.
Great.
All right, great feedback. Appreciate it. Any other questions before we sign off?
Hey, thanks everybody for joining us. We'll upload our video to YouTube and send some notes from today's tutorial, and look out for the invitation for the next one. As I mentioned before, the next tutorial will be on all about charting, a deep dive.
All right.
Thanks, Mike.
Thank you. Have a good rest of your day.
Thanks, everyone.